Next, there is this Google Forms to record or upload. It's defined here, and the number of seconds to record is defined here. So a minimum of 1 second, maximum of 10 seconds, and in steps of 1. Then it will check if it's record or upload. Then if it's record, it's going to call this function record. The argument seconds is equal to the record seconds, which is defined here, and then there will be this audio variable. We will store the return what this record will return. If it's not record and it means it's upload, then it will call this upload function. Then we'll get file names and audios. Then it will print extracting audio features. So later on it will call this specplot audio and play audio. So specplot is here it plays the audio, and it will compute the features. So it will use the start time to calculate the time that it takes to extract the features. And here is their printing. Print audio features took 2.6 seconds in this case. So they have the time minus the start time. That gives you the time it takes to go execute this features computation. So they have here from the DSP training metrics compute audio features. It will be stored in audio features. Then the audio features loudness dB. Here making as type of float 32. Setting the audio features mod equals to none. We will check it out later. And they're defining some trim value -15. Then they are plotting the features, and this will be these plots here. So we have the loudness, F0 MIDI, F0 confidence. So audio features, it is calculated here, and there is a dictionary. We have a key loudness dB. We have also F0 hertz and also the F0 confidence, and here we see now that they are using the string -15. So they are taking from the beginning of this array until the end -15. So they are using a lot of functions now. We need to start looking at what are these functions doing. I will add one code cell here. The first what we see here is this function record. So let's investigate what record is doing. So here it is. This record. Record audio from the browser in Colab using JavaScript. So if you are familiar with Google Colab, you know that this is a remote server and we don't have access to a microphone that is connected. It could be connected to a remote server. There's no way we can use it, so we need to use the audio from our computer. So we use it through the browser. There is a tutorial on Guitars AI channel, and it's about the introduction to Google Colab for research, and there is a specific tutorial there with recording audio from the microphone. If you want to know more about recording audio from the microphone, you in Google Colab environment, you can take a look at this tutorial. But let's continue here. There is some arguments to this record function. Seconds is the number of seconds to record. By default is 3, but here we are using this, what we defined from the Google form. Then the sample rate is the default sample rate, and there is some normalized dB. So this normalizes the audio to this many decibels, and returns an array of the recorded audio at that sample rate. So here we have the JavaScript to record audio. There is this record.js code, so this JavaScript code. Then it will have some printing, starting recording for that many seconds. Then it uses the display JavaScript to run this JavaScript code. Then we have an audio string, which is the output.evolve.js. And then we have this finished recording, and we will have this audio string. It will use this base64 decode, so we will have our audio bytes, and then it will return this audio bytes to NP, that will convert this audio bytes to Numpy. And this function is here from the DDSP library Colab utils.py. So we could have a full tutorial just on how to record audio using JavaScript. That is not the purpose of this tutorial. So you can use this function record to record audio, and you can use in other projects if you want. So if you want to investigate even more, what you can do is, here we are at the Magenta DDSP, and you can go here to GitHub to the DDSP Colab utils, and then you see this library with these helper functions for running the DDSP in Colab notebooks. So for example, here they import base64, and they were using base64 there. It's decode the base64 encoded bytes like object or ASCII string S. So this is, for example, when we went back to this record, they also will use this audio bytes to NP. So we go back here to the Colab utils, and here there is the definition audio bytes to NP. So it converges audio file data in bytes into a NumPy array using PyDub. So it takes as an argument a byte stream of audio data, a sample rate, and the normalized dB. So to normalize the audio to this many decibels, you can set to none to skip, and it will return an array of the recorded audio at that sample rate. So we took a look now at the base64 and also audio bytes to NP. So at this point, we will have our audio if we recorded by ourselves. But if we didn't record by ourselves, we can also use this upload. So let's investigate this upload. Close this. So upload. This is a function also from Colab utils that loads a collection of audio files from disk into Colab. It can be a WAV file or an MP3 file. As an argument, it takes a sample rate, so we sample recorded audio to this sample rate, and we also have this normalized dB that normalizes the audio to these many decibels. It will return a tuple of lists with file names and NumPy arrays. So this is why we have here tuple file names and audios, and then we are selecting audios 0 to be our array, and it also uses this audio bytes to NP. So here it creates a audio empty list and append this file audio to this empty list for fname in fnames. Fnames is a list audio files.keys, and audio files is used using this files.upload. So we go back here, we see also the upload. This is the same definition what we seen before. So probably this files is from Google Colab import files. Let's investigate also this part here. Files.upload. So files upload, render a widget to upload local to the browser files to the kernel. So we have some HTML code that's being displayed, and it's used to upload the files. So what does it mean? It means that if we use here upload and then we will run the cell, so now it's displaying here this HTML that we can choose files, and it will open a way so we can import our files. So it's calling this upload function from the Google Colab utils, and inside this Google Colab utils it also uses this files upload. This files upload is from Google Colab files.py. So if you're interested in understanding how you can use some also JavaScript and HTML to upload files, you can go deeper here in this code. I also use here the base64 decode, and this is what they are using here to record or to upload the files.